Welcome everyone to the course of the solid state electronic devices. Here we are going to discuss the module number 8, that is PNPN switching devices. The topics which we will be looking after are the introduction for the PNPN switching devices, the device structure, working of such devices, semiconductor control rectifier SCR and its basics. It is one kind of the PNPN switching device. Then SCR, its structure and working, and the bilateral devices. The basic PNPN device looks like as the one shown in the figure. It consists of four back-to-back alternate PNN regions. It has three PN junctions which can be known as J1, J2 and J3 junctions. The two terminals are known as the anode and the cathode according to the region which they are connected to. So the junctions can now be the forward bias junction and the reverse bias junction. When the anode is positive with respect to the cathode, the device is said to be forward biased, and the reverse configuration is known as a reverse bias. That is, when the anode is negative with respect to the cathode is reverse bias. However, the forward bias states for such devices have two modes of operation. These two modes of operation are the forward blocking mode and the forward conducting mode. Whereas the switching between these two modes take place at the onset of the critical peak forward voltage. So the forward blocking mode, that is the V positive, in this the J1 junction and the J3 junction are both forward biased while the J2 junction is reverse biased. But after the critical peak forward voltage, that is the device when it reaches this critical peak forward voltage, device goes into the forward conducting mode. So the device exhibits for the forward conducting mode, this device exhibit low impedance state and allow current to flow. That is, the device is into the conducting mode. It has stopped blocking. All the three junctions, that is J1 junction, J2 junction and J3 junction, are now into the forward bias mode. So now the third mode of operation, that is the reverse blocking mode, that is V negative, is the one in which the junction J1 and J3 are reverse bias and the junction J2 is forward bias. Because of this reverse bias, the reverse bias junction lead to the blocking of the current through the device terminal. Hence, no current flows in such reverse blocking mode. So now we move forward to the working of the PNPN as a switching device. It can be visualized as the combination of two transistors. One of the transistor being the NPN BJT formed by the junctions, that is J1 and J2, and the other transistor being the NPN BJT formed from the junction J2 and J3. The implied figure of such a visualization is shown in the figure. In this configuration, the basic of the PNP forms the collector of the NPN and the base of the NPN forms the collector of PNP. That is, the base of PNP forms the collector of NPN and the base of NPN forms the collector of PNP. Thus, the base current of the PNP equals the collector current of the NPN and vice versa. So in this, there is a triggering mechanism for such a device to get into the operating mode. We have the triggering mechanism. These triggering mechanisms can be thermal agitation, optical injection, or the voltage triggering. For the thermal agitation, the charge carriers are produced by the thermal effect. For optical, charge carriers are produced from the optical rays. Semiconductor control rectifiers or the SCRs. While the PNPN diode is switched by controlling the voltage across its terminal, the SCR is switched by controlling through the third terminal. The SCR, that is a semiconductor control rectifier, is a modification of the PNPN diode discussed till now. It is used in power switching applications like dimming, and it can handle the current with a range of few milliamperes to the hundreds of amperes. The pictorial representation of the SCR is as in the figure below. The structure and working of the SCR can be as follows. The 3 terminals SCR is similar in structure to the PNPN diode, except that it has a third metal contact attached to one of the base region. This third pin is known as gate. The gate current helps in sweeping the carriers across the junctions, thus increasing or enhancing the injection efficiency. Hence, the switching state is achieved at the lower values of the VP, that is a peak voltage. So once the device switches to forward conducting state, gate current no longer has any effect on the working, and the device can remain in the conducting state for the infinite long duration. Hence the SCR are used very commonly into the switching applications. The switching devices discussed till now, that is the PNPN devices or the SCR, they exhibit their characteristic switching action only in the forward bias mode. However, by making suitable modifications in the device structure, the device, that is a PNPN device, can be made to switch in both the forward and reverse bias mode. Such a device is a bilateral switching device. That is, a bilateral switching device can be switched in both the forward and reverse biased by making suitable modification in structure. These can be used in switching applications which involves the AC waveforms. If the bilateral switch is properly designed, it shows symmetric characteristic in the forward and reverse bias regions. Thank you.